We're supposed to find this side length. So if we have a right triangle, then we should be thinking about sine, cosine, and tangent. So sine takes in an argument of an angle, and it says that the sine of an angle is equal to opposite of this side. Opposite of this angle, I should say. The side that's opposite of the angle divided by the hypotenuse of the triangle. And if you look opposite of this angle, that's got A. That's what we want. We want to deal with A somehow. So let's take angle 64, the angle of 64 degrees, and we're going to evaluate sine of 64. That should be the opposite of angle with the 64 degrees, divided by the hypotenuse of the triangle. You could try cosine of 64, but that would take B and divide it by the hypotenuse, because cosine is the adjacent divided by hypotenuse. If you try to do tangent, then the opposite over adjacent is tangent. That wouldn't be any good because you'd be trying to solve one equation with two variables. So since we're looking for A, I want sine because sine deals with the opposite and the hypotenuse. Okay, so round our answer to 2 decimal places. So let's find out what sine of 64 is. So that's sine of 64. To get A by itself, I'm going to multiply 11 to both sides. So it looks like A is roughly 9.89. This question's a little bit different though because they only explicitly tell us one angle. The angle C is 90 degrees. We could use trig to solve for an angle and then do what we did in the previous problem, but a quicker way of doing this is recognizing this is a right triangle, so the Pythagorean theorem can apply. And the only one that really matters to get right is to get C in the right spot. C is the hypotenuse, so 16 has to be C. And that means we'll just put 10 in for B. So 16 squared, I probably should know what that is as a math teacher, but I don't. 256. So I've got 10 squared, that makes 100, equals 256. I'm going to subtract 100 from both sides. So I get A squared equals 156. And they want an exact answer, so I need to take a square root of both sides. And let's see if we can simplify that square root. Can I divide 156 by 4? I can. Maybe I could divide something else. But here, if you divide 156 by 4, you can break it up into a square root that turns out to be an integer. So we're simplifying the radical. Okay. So A is 2 square roots of 39. And you would want to check to see if there's any others, like dividing by 4 won't work because this is an odd number. Divide by 9 doesn't turn out even. Obviously 16 won't work either. You just want to see if you can factor out something where the square root is an integer, like 4, 9, 16. So that looks as simple as it can go. So 2 square roots of 39. So we're given these two side lengths. We're supposed to find the values of sine of B. So sine of angle B is going to be whatever is opposite of angle B divided by the hypotenuse of the triangle. And cosine of B is going to be the adjacent to angle B. And there's two angles that are next to it. One of them is the opposite, so the other is the adjacent, divided by the hypotenuse. So looking from B's perspective, actually we need to know what C is in order to finish this out. So let's do that first. 6 squared plus 7 squared equals C squared, because C is the hypotenuse. Uh, 36 plus 49, that makes 85. So C is going to be the square root of 85. Let's see if we can, I don't think we can reduce that, because you can't divide it by 9 and get an integer. 16 won't work, 25 won't work, 36, 40, can you divide? No, nothing will go into that. So that's as simple as it can go. So sine is the opposite, so that's 6, divided by the hypotenuse, square root of 85. Or if you rationalize the denominator, that's 6 square roots of 85 over 85. Multiply the top and the bottom by square root of 85. And this one, cosine is the adjacent, so this is what's opposite of angle B. 7 is the adjacent, square root of 85 is the hypotenuse. So it's 7 square roots of 85 over 85.